Good afternoon. I am Heidi Kurtz of the National Association of Energy Service Companies, and welcome to our first webinar of the year. I just have a few housekeeping things I'd like to go over. There will be a CEU unit available for this webinar. Um, I will send you instructions, or you can email me at heidi.kurtz@nasco.org for if you're interested in getting credits. I think we're still waiting to hear on final approval, but we should have that any day now. So if you do need a credit, let me know. And I will also send an email about that later this week with a link to the presentation and a recording if you need to listen again or if you're looking for any information. We will make that available. Let's see. Okay. While there's been a lot of fanfare and hype regarding IoT in the building automation space, we wanted to do a webinar how IoT can deliver results. As we all know, performance contracts require guaranteed savings, so even new technologies need to deliver results. Today, we will discuss what can be gained by connecting buildings and their systems to the Internet of Things. Learn how IoT is not a replacement for building systems and how BAS vendors are leveraging IoT to extend the value of their systems. We have 4 speakers today. I will introduce them all right now, and we will get started in just a second. Our first speaker is Teja Kuruganti. He's the group leader of modeling and simulation at Oak Ridge National Laboratory. And then we will also hear from Julio Ampuero from Honeywell. He is the sales director for connected buildings. Our third speaker is John Parrish, director of connected lighting development at Johnson Controls. And our final speaker will be Jim Phelan, national sales manager of building IoT solutions at Siemens. So I'd like to thank all of our speakers for participating today, and thank you all for joining our webinar. And without further ado, I will hand things over to Teja.
Okay. Good afternoon, everybody. Let me see how I click through. Oh, got it. I'm Teja Kuruganti. As Heidi mentioned, I work at Oak Ridge National Laboratory. A lot of my expertise is in sensors and controls for building technologies. What I am going to do is give a high-level overview of IoT and expose a few dimensions of IoT on what kind of applications are feasible and where do buildings, what is the vertical market for buildings and where do technology fit in. These are all our speakers today. So I wanted to start with the magnitude of energy consumption. So I work at a Department of Energy laboratory. So it's always important for us to look at what is the energy consumption, particularly in this case. What I'm trying to show is if you look at just electricity consumption in the US, about 74% of the total electricity produced in the US is consumed by buildings. So that's a pretty large number. That's residential, commercial, all of it included. There have been several reports to show that significant amount of savings are possible if you deploy sensors and controls, advanced sensors and controls into buildings, primarily just to observe the current state of the building and then improve its efficiency by adaptively control the variety of building equipment devices, be it HVACs, water heater, and other devices. There's another benefit to having this advanced connectivity inside buildings is you can see the third column is there's a huge value in demand dispatch. So if we're talking about 74% of the total electricity load, so if you look at total energy consumption, it's about 46% if you include gas and electricity. There's a big potential if buildings can participate in demand side activities in a larger scale. There's huge benefit both for the utilities and both for the building owner, particularly rate structures and things like that. Traditionally, the large aggregation of this load, if you see the 74%, that looks like a big number, but not a single entity owns like 2% of that energy footprint or electricity footprint of the buildings. So to bring a large number of these buildings into one big cohesive unit so you can actually do some load shaping requires a lot of automation, right? And if you look at the building slot, about 50% of the buildings by number are less than 50,000 square feet, roughly around small, medium commercial buildings. And almost, a significant percentage of them don't have an automation system. So my point here is there is a large market where retrofit sensors and controls, which we are calling or defining as IoT, is a big opportunity. So what does IoT enable? Like I mentioned, today's talk of buildings, or when you take aggregate numbers in hundreds of millions, largely unconnected. And typical automation systems are for existing applications, primarily to run the building purely for existing strategies, control strategies or automation strategies. If you look at even in that sense, if you look at automation, it's typically in large buildings greater than 100,000 square feet is where, or 100,000 square feet, that's where you see a good coordinated automation system that gets placed and run within buildings. For going beyond typical building automation systems in this particular domain, the value streams are often hidden and untapped at this point. They're evolving as we speak, particularly in the last 5 to 6 years. Quite a bit of evolution is happening, but there's still a lot more potential in doing that. Where apart from improving the building automation and apart from improving the energy efficiency of the buildings or providing energy services, there's a big push on using this flexibility or creating the flexibility on from the building side, so you can bring in more clean energy technologies. For example, if the distribution system, electric distribution system located for solar photovoltaic or any DERs like that, which are generally uncontrolled, you receive the energy in a time varying fashion. An integration with the building can modulate its load shape in theory to absorb a lot of this energy and increase the penetration of these technologies into the grid. We'll talk a little bit more about that later. So the first thing, if we focus on the large buildings, integration of BAS and IoT approaches for deploying technology can enable new services. Starting from what you see on the left side, typical sensing measurement, things that you want to measure in a building, and you want to measure in a building, particularly if there is a heterogeneous building automation system, heterogeneous set of vendors within a building. How can I bring all of that information to one place so I can make comprehensive decisions, either for a efficiency application or doing applications like peak demand while maintaining the comfort constraints of a particular building occupant or an owner. These technologies can certainly help. The key to understand is this is probably not a strict number. We're starting to look at ROIs that are in reasonable number of years. A lot of the things that we will start seeing is as you bring in new technologies, the integration cost, in the end, the electricity rates are still at a lower cost for a large investment to be recouped. So we have to understand that in our requirements to sorry. I think I clicked one too many times. In our requirements, we have to understand that that ROI is very important. So that makes our integration choices, technology choices, and deployment choices very related to the cost. What is IoT? I tried to simplify what is the definition of IoT. Internet-connected sensors and controls devices that are in buildings that are either interacting with the building equipment, understanding the environmental parameters of the building, or looking at some indicator, some sensor that is indicating the health of a particular piece of equipment, collectively getting that information remotely, so that a remote monitoring and operation and having the data at one location, so that you can develop novel applications. So that's kind of in the crux what IoT is. What kind of applications can it enable? Improving energy efficiency is high up in there. Improving occupant comfort. So understand the occupancy patterns within the building and control it adaptively. So you improve comfort and improve efficiency, reduce cost of operation. Next is enabling grid interactive operation. That could be as beginning as peak demand and kind of following time of use rates, all the way to providing some innovative services by dipping into the flexibility of the building loads, which is traditionally been very stiff. Buildings consume. It's not a two-way interaction where you could actually modulate the consumption. And finally, advanced controls. As we see this kind of intelligence that you can gather from sensors and fusing that information, fusing that data into some information and knowledge, so that you can do adaptive control to improve resilience of a particular distribution circuit, improve resilience within buildings, adapt to things that are going on outside the building. So as we go forward, we will see a lot of these applications. You can see a popular technology roadmap on Internet of Things, going all the way from just understanding that a device is there to measuring quantities and deploying vertical applications, and all the way to being able to interact, bringing in your AI, machine learning kind of techniques, being able to interact with the environment in a much more seamless fashion. What is the next generation? We've seen evolution in sensors. The first generation was purely put in the sensor. They're typically termed as dumb sensors. Data focus, gathering the sensor data, typically flat architecture. There's no intelligence. Gather the data and then have somehow to process that information. The second generation, what we're seeing right now, is more smart sensors. The sensors are deployed with an application in focus, an algorithm or a higher level intelligence drives how the data is sampled, how the data is collected. In the end, all the sensors contribute to answering questions that the analyst or the user or the occupant have for deploying these sensors. And still, the intelligence is local to a particular portion, a VAV box, or we're still trying to look at how can I understand the operation of a fan and things like that. As we move forward, we will see agents where we can scale with a dynamic architecture where you have network intelligence. You can bring in variety of sources of information, be it within the building or external to the building, weather being a good application, looking at weather fronts coming in and how to prepare dynamically for those weather fronts. We will see applications like that where you're providing a network intelligence. So is the market responding? So there are a couple of indicators. Lux Research had a report. Significant investments in building energy management systems, transitioning from BAS dominant in these buildings to building energy management system, BEMS, where you have more application focus and more hierarchical architectures that are actually gathering information to actually feed into the intelligence in operating and a sort of doing continual commissioning as opposed to commissioning it at one time. So reevaluating the assumptions, reevaluating the current state of the building. As the building degrades, how should we behave to stay on the optimal energy efficiency point and things like that. Particularly in the US, the market for sensors and controls is projected to grow quite a bit. When you look at, when you abstract a lot of details, what we're looking at is a set of sensors and configuration information feeding to some supervisory controller that is actually making decisions to the building equipment and also archiving data for other reasons, model development or whatever. This is one instance of a simple representation of what are we doing with sensors and controls as we go towards IoT-driven automation systems. Why is this possible now? Why is if you see the Gartner curves on hypes and possibilities of this technology, There is generally in the industry, there is an integration of functionalities happening right now. So in the electronics market, electronic manufacturing in particular, and data and business models for how the data can be used and to enable new applications. A lot of this, being able to have sensors that are low cost, be it flexible electronics manufacturing, in general electronics manufacturing, being able to bring those sensors into devices. Your phone is a good example where, about 10, 15 years ago is when sensors started proliferating into the phones, and now we have several, about 8 to 10 sensors, critical sensors inside the phone that tells us all the way from positioning to whatnot. Bringing that sensor, communication circuitry, and energy storage, or some form of energy storage that is meaningful for a long lifetime of a particular node, computation, particularly very low power computation or low power processing, all of this is merging, and that's what enables a single wireless sensor device that we can have 2 to 3 year lifetimes very comfortably, doing samplings at 10, 15 minutes per reading. So bringing all this together, that's happening right now. So that's what is driving a lot of the innovation in this. So the data is much more readily available with devices that are not that don't have to be very tailored for an application. You can have a general purpose with some standardized communication, very low power communication circuitry, and you can start receiving data. So adding value with that data makes meaningful at this point. What within the buildings domain, what kind of sensor requirements are you looking at? They tend to be, when you're thinking of an IoT application in a building, these are non-orthogonal requirements. One depends on the other, so they're not orthogonal. Application requirements, integration, and cost, these three things play a big role within deployment of IoT technologies in buildings. Integration requirements also play a primary role, which tells you how a particular framework, existing applications. If we look at a lot of US buildings, significant portion of the buildings that would exist in the next 10 years are already built. It's a pretty high number, upwards of 90+%. So going into a retrofit fashion where my integration requirements don't drive cost is very important. And then obviously there are emerging standards that can build in requirements for next generation of buildings. All of this data will feed into a variety of intelligence. So there is definitely a sweet spot between what is the complexity of models that I want to use for driving decisions or decision-making capabilities, and then there is a cost of number of sensors. So if you put too many sensors, it's expensive. There's a point at which there is not enough information that you're getting in return for the investment cost of the sensors. And similarly, if your models get too complex and you're using less number of sensors, the models can diverge from reality, and verification and validation of these models can become very, very difficult. So that understanding that sweet spot is what is enough number of sensors to actually drive your particular application is the key when you're deploying IoT. So what kind of algorithms? Just a snapshot. I have a few slides just to give a snapshot of kind of applications that can be driven. The way to view this slide is look from bottom up. You can have discrete failures that can be detected, threshold-based detection, dirty air filter could be a simple example, sensor-based direct detection. And as you go layers above that, you would have algorithmic detection, which requires taking sensor information. For example, you could put a vibration sensor on a HVAC unit and can tell a lot of what's happening with the compressor, but it requires you take that vibration information, do some Fourier analysis, and or a power sensor, do a current signature analysis, understand what's the normal behavior, teach the algorithms what's the normal behavior, so that they can pick out the abnormal behavior as they happen, to do some condition-based maintenance and things like that. And then all the way up to prognostics and health monitoring. Can I catch before I lose 5% refrigerant charge? Can I find out about that in a particular HVAC unit, so that I can schedule a technician to go in and bring the charge up and whatnot? So how do you make those decisions, and how do you make them reliably? You'll have to start looking at models that are verified and taking in this sensor data, doing some processing and some contextual intelligence of what's happening inside the building to make those decisions. The other big application, so we talked about a lot of what I talked about before is related to energy efficiency. The other major activity that's coming down the pipeline is building to grid integration, sometimes called transactive control. We do quite a bit of work in this area. Is now that we're talking 74% of a large load that is on one side of the utility systems, can we coordinate these loads? Can we bring all these loads together for two key reasons? One is reduce the energy intensity and increase energy efficiency, which is a goal that we have, and everybody I think would subscribe to that. And then can I have some control on exploiting some load flexibility while maintaining constraints within the building? If the occupants are not comfortable, then it doesn't make any sense. To improve grid resiliency, to key applications. So at this point, you have to start, grid usually asks in megawatts when they want to have some resource. Buildings consume in kilowatts or tens of kilowatts. How do we coordinate a lot of buildings to make it look like a resource that the grid can utilize, and vice versa? That requires advanced control systems that actually bring in the sensor data, make decisions, and timely control these devices within constraints, both the equipment safety constraints and also constraints related to the building occupant comfort. So there's a large role for IoT. What kind of services are we talking about? As you go down this scale, the services become finer in control time constant, so smaller time constants for control, going from energy efficiency, peak shaving, shifting, all the way to reliability response, where if utilities have some reliability issues, can buildings participate, engaging DERs, and very futuristic look is to look at regulation response. And IoTs can enable a lot of this. So I wanted to throw light on a couple of things. One is when you're thinking of IoT, they typically use cloud-based data aggregation platforms. So you have to think about that. So the building's connectivity to network and buildings, and depending on an application that actually depends on a cloud-based connectivity is very important going into it at a requirement space. It has its advantages, obviously, so that's why we use it. Is scalable analytics, rapid application deployment as the data comes in. It's easier to manage information. It's easier to deploy new applications and scale very gracefully. Few things that needs to be understood. This kind of architectural change where building automation systems make all the decisions inside the building to the large portion traditionally, to taking the data into a cloud, it could be a private cloud. There is you're closing your control loop over this cloud. So that's why I call it a cloud in the loop control system. So people who look into feedback control systems, they have to understand when you're closing a loop on a particular system, you have to understand the latency and reliability of it, what's in the loop. You have to understand the data security and authentication requirements as your data is being communicated, because these are not individual users. You'll have hundreds of sensors going through these devices. So automated mechanisms that you can trust and verify are the key. And understanding these requirements early in the design phase as opposed to after deployment makes a big difference. End-to-end building applications, they're very possible for this cloud in the loop style of deployment that we're talking about. Understanding API considerations to integrate multi-vendor systems becomes a key. Couple of examples. I've done some of this work in the past. What would we try to show? There's one particular example of a building where it's about a small building, about 140 sensors. We're trying to see what can we maximum save in a building. About 75% of these sensors, you can see the sensing modalities on the left. We're pretty much sensing everything that we can. Just a note, this is an R&D project, so not the real world. So there's a lot of leeway there. We showed about 55% savings in energy for this small building, or medium-sized building. So just to show the potential of what you can do if you observe everything and have intelligent algorithms that can be used for control purposes. Some other examples, why is IoT feasible right now? A couple of things I talked about is the integration of multiple technologies is coming into picture. So this is one example where we're looking at really in the future, what we're looking at is, can I peel and stick a lot of sensors across the building, very low commissioning, and these sensors would be printed on plastic and would have a small solar cell. We built a prototype of this. This is about the size of a single switch wall plate, and it would sense multiple parameters. And then once I deploy that sensor, I don't have to maintain it. It's got a storage mechanism, and it's got some PV-based indoor light harvesting devices. So there are already a lot of efforts across the country where we are bringing in low-power wireless, flexible electronics, thin film electronics to bring in devices like this where commissioning is extremely easy, which is a key to deployment inside buildings. So I don't like to end the presentation. I always like to show something about interoperability. This is a picture that I got from somewhere. You can see, if you do not if you do not understand your requirements for interoperability, you could end up with searching for adapters to make the application work, which will drive your cost. So things to think about: protocol level interoperability. What's the existing building automation system? BACnet, Modbus, LawnWorks, or N2, Metasys, and whatnot. How do we connect these new technologies that I'm bringing in, where I have a promise of a new application, but how do I do that? An application level interoperability, where you could go in, access the device performances using RESTful API or some other mechanism, or a proprietary API that you have to interact with devices. Understanding these two particular interoperability and integration requirements is the key for reducing the cost of deployment. So I'm going to conclude here. So significant energy efficiency gains possible with ubiquitous sensing. There's a lot of studies and reports shown, and technology is merging to realize this potential. At the same time, there is a dual application where reliability of grid can be improved with responsive loads, which is buildings in this case. The key is to incorporate the intelligence in low-touch retrofits. If the building deployment and commissioning costs increase, the adoption rate decreases. So seamless deployment requires plug-and-play connectivity, automated response. Your control strategies have to be really reliable and do not impede on customer constraints, and interoperable. So I'm going to stop right there and then hand off to Julio Ampuero from Honeywell.
Thank you very much, Teja. I really appreciate the setup, the background. From the perspective of my presentation, I build on a lot of the comments that Teja made around the technology, around the capabilities of both physical systems in the building and cloud. And the perspective that I bring is that of both a manufacturer and a service provider. So at Honeywell, with over 100 years of experience, being present in over 10 million buildings, and in that period of time, those systems continue to collect data. We recognize that the next level of opportunity is to be able to turn that sensor data into valuable information for insights with the customer. In addition to that, buildings have been constructed and operated in similar fashions for many, many years. Those who've been in the industry for a while will recognize that we're seeing a tipping point, and that tipping point is really beginning to understand that some of the building data collectively beyond the single building into an enterprise level, a portfolio level view is going to be very, very insightful to drive more outcomes. But also we need to be thinking beyond just the data that we have in the buildings associated with energy, which is important, comfort and safety. We need to be thinking about, I need to go back up one slide. We need to be thinking about that some of these solutions, if we're enabled by the cloud, could help us also bring some additional value to the occupants in the spaces. And I want to share with you a couple of the very specific use cases that now can be enabled based on the ability now to connect the physical to the digital. And this transformation is happening every day. And if you look at the cost of energy on the average of $3 a square foot in North America, $2 to $3 a square foot, we look at the cost of spaces in North America. It's one order of magnitude larger, maybe $30 per square foot. And if we were to take a broader view and we think about the cost of occupants, the value of occupants in a building by just looking at their salaries and fringes divided by the average square foot of a building is one order of magnitude larger. So we believe at Honeywell, in our colleagues and competitors who are on this call, also believe that there's some natural adjacencies as well that we need to be looking at. The area of occupant experience and space utilization are two areas that would inevitably complement the notion of cloud and IoT solutions that are delivering results today. So the notion of occupant experience is to understand that the occupant of a building has, in particular, when you think about the next generation of worker, the multi-generational workers that we have in the workspace today, have a recognized expectation and an entitlement of having the ability to connect their physical spaces, both as they do at home, as they would want to do it in the workspace. They want to be able to have mobile apps that allow them to be able to turn things on and off like they do at home. They want to be able to have a comfortable and productive environment. So we put an umbrella around that and we call that occupant experience. So we will continue to see more and more expectations to be able to drive that mobility of occupant experience into the building, thus addressing the question and the point of this webinar, which is delivering more than just hype, both with IoT and building automation. So think about the ability then to connect the occupant to their environment. The occupant has the ability to control the lighting systems and the comfort systems in their building, enabling both improve operations and improve efficiency of the building, but also recognizing that if there's a problem in the building, they would want to be able to have the ability to close that loop by sending a message to the facilities teams or the maintenance teams to make corrective action happen and then receive that feedback on their mobile app. So that's the occupant experience concept that I wanted to share with the audience. But also, if we think about the next adjacency, which is understanding that 50% of the spaces in commercial buildings are being not effectively utilized, we believe that the opportunity that exists with the sensorization in buildings, which is happening with concepts like Teja mentioned of lick and stick beacons, to lighting systems and luminaires that come with sensors that are cloud enabled, that sensorization, particularly when you look at it in the context of a lighting retrofit, now you're creating the opportunity to present a next generation of energy conservation measure, or ECMs, that doesn't just look at traditional lighting systems, but could also be enhanced by understanding how spaces are utilized. So if you think about how spaces are utilized and you had that knowledge and insight, you would probably operate your systems differently. You would probably look at occupancy-based ventilation. You would look at occupancy-based starting and stopping of equipment. You may zone your building differently, and you would operate your equipment more efficiently, resulting in energy conservation. But if you think a little bit further than that, and you recognize that a significant cost of maintaining buildings is cleaning and services and other areas that oftentimes are primarily schedule-based, this level of automation and cloud capabilities then begins to open up new opportunities for the building managers and the building users to create more different level of services in the building. One example of that we see frequently is the notion of demand-based cleaning, whereas sensorization in buildings is reducing the redundancy of sending cleaning staff in areas that are typically scheduled just based on time of day or evening or weekly or bi-weekly cleanings. If you had the sensorization, you will recognize wear patterns, flow patterns in the buildings. If you sensorize bathrooms, for example, you may be able to see that usage also has a direct correlation on the need for cleaning. So those will result in additional benefits. So occupant experience and space utilization are examples of additional capability to help drive real value in IoT with building automation systems, resulting in reduced energy and improving the experience of tenants. But if we take that, one step further, and we look at, the notion that today, in order to connect information in buildings, you typically have to have a homogeneous type of technology that today is very difficult to accomplish. Most every building has a different control system. Many different control systems are different vintages. So the notion of connecting 10, 100, and 1,000 buildings at a time is really a significant boundary that we've seen in our industry. And the answer, recently in current discussions in industry is around open protocols. Honeywell believes that the opportunity that we have in front of us with cloud, open systems, newer technology and sensorization is to be able to build a much greater capability to connect buildings by the tens or the hundreds or the thousands, and make that in a way that it future-proofs the investment of the customer by leveraging machine learning, artificial intelligence, self-learning systems, and create open platforms that enable multitude of vendors to operate in those platforms. Honeywell this month is launching a platform called Honeywell Forge, which really addresses those particular needs of building owners that have 10, 100, or 1,000 buildings. So we offer initially in our capabilities the ability to look at a portfolio of buildings. Those buildings may or may not have Honeywell systems. And also we're driving building operations effectiveness by now being able to look at the aggregate data of tens and hundreds of thousands of buildings based on the a central cloud strategy that both looks at the data sets. It has greater computing power and capability, and it leverages predictive analytics and predictive diagnostics, not just for energy management, but also for additional insights with data sets that today the building owners don't have access to. So I encourage you to go to the Honeywell website, www.honeywell.com, and look at the header Honeywell Forge, which is this Honeywell-wide platform. I have responsibility for the building side of it, and we're seeing tremendous insight and appetite for customers to be able to connect their buildings at a portfolio level. But the purpose of this call, of this discussion and this panel is really to look at true proof points of value with IoT. The initial panelists really spoke about the technology and the capabilities, but from experience of being in this space for the last 36 months and having hundreds, if not thousands, of buildings connected into the cloud with our existing platforms, we see significant benefit. And I've cited a couple of examples. One is a very large entertainment area in Australia. We have also a multi-location customer in England. And in addition to reduction in energy through predictive analytics and diagnosis, we also see the opportunity to improve the operational efficiencies, not just with occupant comfort, but also beginning to look at eliminating the traditional maintenance tasks that are repetitive and are schedule-based, and begin to create fully predictive needs, whereas only those elements of the building that are analyzed and through continuous technology, and those are determined that they're going to fail, those are the ones that are being taken care of. So energy using, improving comfort, reducing the number of repetitive tasks really is the true value that IoT has to offer. So with that, just wanted to be able to close, and thanks for having the opportunity to present. I look forward to some of the questions, and I'll turn it over to my fellow panelists from Johnson Controls.
Thanks, Julio. Can everybody hear me okay? Yep. All right, so I'm John Parrish. I'm our director of our Connected Technologies group at Johnson Controls. I'm going to take my direction on this presentation a little more in the direction of overall lighting, because we are seeing a lot of exciting things that IoT is bringing from the lighting industry aspect and integration with building automation systems. The JCI vision is that we're now a buildings products organization where lighting is a very important component to the rest of the building automation system. I want to talk about a little bit about some of the recent emergence of cost-effective connected IoT-based lighting controls that we're seeing, and Julio and the first speaker here talked a little bit about that, where we're seeing this immense drive with sensors and sensor technology coming down very cheap, and we're starting to see a lot of really interesting things come out of that. But when I think of compatibility, interoperability, and interchangeability, I think of two overall categories in my line of work. I think of lighting as in the hardware, and I think of the controls, which is increasingly becoming networked. From a compatibility standpoint, in the past we've had limitations on these devices. We had different form factors, voltages, the service use, the environment. These narrow categories that fixtures had to be fit in. Now what we're seeing is a greater expanse of how these systems can exist on existing networks without interference with other systems. From an interoperability standpoint, that dimension of communication, today connected lighting systems are able to tap into a vast amount of data, right? And when you see this, in the old ways, we were doing dry contacts, relays to communicate that. Now we're starting to see a lot of data that can be software driven, which seems to unlock an enormous amount of potential with the systems. And there's emerging standards in development, the protocols that we use, and I know a lot of other people out on the phone are using, like BACnet and open APIs, or opening doors to bridging them to building automation systems. And then finally, from an interchangeability standpoint, it looks like at least on my screen, it looks like that word may have got dropped off. But the big thing we see is the data privacy and security. It's going to take some time to resolve that, but we're starting to see a lot of advance in the LED lighting industry that's allowing us to do connections between the systems. Where we really want to see the industry go is to more of a plug and play type standard, and we're starting to see that a little bit, but I think that's where a lot of us want to see it goes, where we can have different devices talking to each other easily. So all these systems here on the right, they all live within a building: security, fire, lighting, energy storage. But the question my team is constantly asking is, how does lighting fit into the overall IoT structure to make a building more connected? And we think there's a lot of ways that we can make these connections safer and more secure for building occupants, but the primary beyond the connection, connection standpoint. An example I've heard in the industry, and you all may have heard, is, why can't the lighting systems be integrated so that if there's a smoke detector that goes off or a pole on a fire station, that the lighting system can blink in a pattern to direct people towards the exits? Something that the existing technology should be able to give you today, similar to what you might see on an aircraft emergency floor path illumination. So in specific in K through 12, and Johnson Controls does a lot of K through 12. That's probably one of our primary markets that we serve. We're seeing, at least on the energy side of the business, the LEDs are getting more and more efficient, and the low-hanging fruit from the projects is starting to disappear. So as an industry, we need to focus on how we can provide more value. And we think of here as lighting as being ubiquitous, right? It's everywhere. It's all over a facility. It touches pretty much every single room. So we think IoT-based systems can provide a lot of different value from the student's perspective, where you can integrate a system to have color tuning lighting that matches with a student's circadian rhythm. So maybe improving the overall alertness of the student for the day, or helping the student with the retention. Or value from the perspective of a teacher. Can the systems give them additional flexibility with dimming or scene selection so that the classroom time is more impactful? Can those results correspond to improvements in teacher reading test scores or overall learning? Value from the perspective of the parent. Integration between security systems, whether it's through Bluetooth and asset tracking, or other new emergent technologies with disinfectant lighting, where the mechanical systems can effectively clean the schools after hours and clean the classrooms. Or maybe value from the perspective of an administrator. Can we already today have systems that can issue work order tickets when lighting systems go down, but could those systems also show additional value that we can prove out in the community, right? That can go above or beyond the watt, above the energy savings. And then finally, I'd say, the bottom line is, we all here think that there's a lot of value with the integration of these systems put together, but I think the difficult part that we're all going to be looking at in the industry is, how do we monetize these systems? How do we show that value, right, when we're all very used to doing it from a pure energy savings play. And finally, I'll go to my, sorry here. Just very touchy. There we go. And finally, I'll go to my last slide here is a higher education retrofit. This is kind of a micro example of something that we've done recently is, this typically in the past, this would have been something where it was a very conventional fluorescent system retrofit to LED. But in this case, the facility manager had a limited ability to identify how was that building operating during the summer. The building was really operating at full bore, and the facility manager wanted to have a sense of, is this building occupied? Or if it's occupied, is it only a couple students there in the summer or a couple classrooms? So with the solution that we worked on to develop with them is developing a system where the facility manager could essentially manage the lighting system through an integrated sensor and LED kit. So every room got LED sensors and LED kits where it was a high density mesh network of sensors. That information then fed into the building automation system and do more autonomous controls, whether it was through some of the mechanical systems like the VAV box and outside air damper controls, or more importantly, what I think what Julio was just talking about is on the space utilization standpoint, getting a real clear picture of how is that space being occupied. If it's only being occupied 1 or 2 rooms, could those students move to another part of the classroom or another part of the building or another area of the campus altogether? And maybe they could shut that building down during the summer. So I think there's going to be a lot of use for this data, especially on some of our customers that are on the corporate commercial side and then on the higher ed, but there's a lot of use cases out there that we're all looking for within this overall ecosystem. So from there, I'm going to turn it over. If there's any questions, I look forward to answering them. My information's on there. I'll take emails too afterwards. And I think the next up from here is, I believe it is James.
You got it. Thank you, sir.
All right.
You advance me. Fantastic. Good afternoon, everyone. My name is Jim Phelan. I'm the National Sales Manager for Siemens Building IoT Solutions. Great content, and it's good to hear that the industry has got a lot of support and awareness about this new development within our commercial office spaces across many vertical markets. We're seeing the emergence of technology go from the residential sector very much into the commercial sector, and I think that's what makes this exciting and a bit frustrating at times. So what I want to do is, it was great background and some validation and proof points about why it makes sense to put a smart sensor network or a smart infrastructure in a building that can ultimately be adaptive. So one of the many solutions in the marketplace, as you'll find, using lighting as the vehicle for deployment, is a smart sensor network called Enlighted. This solution has been in the marketplace for close to 10 years now. And you can't talk about IoT in commercial buildings without a discussion around sensors. Teja did a nice job defining the difference between the levels of intelligence within certain sensors. And it is important to know that not all sensors are created equal. One of the sensor technologies and sensors that Enlighted uses is a sensor that has several different technologies built into every one of them. Imagine the sensor the size of a dime looking down into the space below. And it has several different technologies, including motion sensing for your passive infrared occupancy type sensing control, light level sensing, detecting both artificial and natural light, temperature sensing, power measurement verification, as well as embedding wireless technology, both RF and local Bluetooth for edge integration. Lighting is a fantastic vehicle to deploy smart sensors. A couple reasons is lighting's ubiquitous. We're always going to need it in commercial buildings. Lighting is always spread, or should be evenly spread throughout a space. And the lighting fixtures themselves also provide power. These sensors, typically low voltage in nature, can be wired to LED drivers within the industry that are providing auxiliary inputs, or there might be another device that sits between the LED driver and the sensor to provide an integration between line voltage and low voltage connectivity. So a typical floor plan would have ideally a sensor for every light fixture. And the reason that is because you need that coverage. A typical light fixture is deployed in a 10 by 10 square foot pattern. Of course, depending on the light fixture, the lighting package, the luminaire style, and the lighting design, and the tasks at hand, the amount of illumination below will dictate the type of deployment for fixtures. But looking at it holistically, a 1-to-1 ratio is typically the deployment. The architecture is then something that is fairly straightforward. These smart sensors deployed at the light fixture are looking downwards, collecting data. At the same time, they are also controlling the light fixture it's connected to. In addition to controlling the light fixture, the data that's being collected is then sent wirelessly to a gateway, which is then wired PoE over a local network. It is only the data that is non-energy savings data is then sent back to a cloud platform for analytics. It was mentioned earlier on that, Teja, that typically powerful analytics and algorithms reside in a cloud platform, and that's definitely the case here. The energy savings is local. So most energy codes becoming more stringent out on the West Coast with Title 24. These requirements are now becoming standard, and you'll see task tuning, occupancy control, daylight harvesting, and now plug load control, all standard requirements in a lot of energy codes. This visibility of use can be realized locally through an onboard energy manager, something that's fairly typical with a lighting control system. So that's the base. But where we see the advantage and the upside to this is when energy savings is realized and potentially in a retrofit lighting situation, which I think a lot of you can appreciate, going from fluorescent to LED, at least a baseline savings of 50%. Once you add a lighting control solution and you filter and you fold in all of these lighting control strategies, it becomes very additive. And you can see a 20-30% increase on top of that by utilizing all these lighting control strategies. So the energy savings realized by installing a building IoT infrastructure will help pay for it. So this is where the added value now turns into an ROI that's not around energy savings. Some great information from the Honeywell side around validating occupants and their costs within a space. The IoT infrastructure is truly intended to make buildings smarter. By doing that, it's connecting to the people in the buildings. If you don't connect to the people in the buildings, you can't call yourself a smart building leader or the developer of smart building technology. Your most important, your most valuable asset within your building is impacted by how your building performs. So it's these unique use cases that can be identified or realized with these smart sensor infrastructures. This is some example of taking that data and using that in a way that turns this into a 1 + 1 = 3 scenario. We heard space utilization, better understanding how occupants use spaces, real-time location services, locating people and assets in real time have value in several different vertical markets. And then as we look at certain markets, maybe K through 12 or education, where security is of utmost importance, having that integrated into card access systems and visitor badging and how that gets integrated into system-wide security systems. Having this IoT infrastructure in place, having the digital connectivity to the other solutions in the building is absolutely critical. I always like to use the smartphone as the analogy that 10 years ago, the smartphone was born. It was intended to be a phone. The only difference that has changed, that has made that product different in the last 10 years is the amount of applications that have been developed. It was a digital device 10 years ago. You can still make phone calls, but the applications that have been developed over time have been significant. So you could still have that Gen 1 smartphone, but an application that was developed today and completely change how you interact with that device. So that's absolutely true with the building IoT platform. The applications are what's going to make it very unique and differentiated. So thank you. I will turn that back over to Heidi, I believe.
Thanks. If you have questions, please submit them and we will get to them as we can with the few minutes we have left. Just a reminder, in case you joined us late, I will be sending around a link to the presentation slides and this recording, probably by Wednesday or Thursday of this week, to all people who registered for this seminar. Okay, people are being shy. Okay, well, if you don't have any questions, I can, as some of the speakers said, we can answer them by email after the fact. And thank you all for joining us today. And we will send out all the info. Oops, wait, one question. Sorry. What are the current known IoT technology providers? I'm not sure who can answer that one. Can any of the presenters answer that question?
Yeah. So this is Teja. I don't think I'm the right person to answer that question, but I think we've seen 3 great presentations today from three good companies. I don't know, maybe Julio or John or James have another.
Yeah, I mean, this is Julio from Honeywell, and I would say that every company that wants to stay in business in our industry needs to have an IoT capability. So the answer is everybody's moving towards enabling sensorization, driving wireless technology, driving seamless integration, cloud connecting, building data for bigger use cases. I just don't think that a company can survive in our industry if you don't do that.
Yep, absolutely agree. I think it's the move towards digitalization. And once these products become digitized, even the 3 large companies that were on the phone today, we don't make all of those digital products that we need to interact with. And so we see these app developers or technology companies that make standalone digital widgets that add value into the larger scheme of a building IoT platform. So as long as there's digital innovation in the marketplace, all of these devices could be interacted.
And I can follow up with the person who asked that question. There's another question. How much work has been done with refrigeration?
So in the R&D land, there is quite a bit of work. There are some large companies that focus on refrigeration. We have one here. Looking at how to understand can I do on-demand defrost, for example, to save energy? Remote monitoring of large refrigerated warehouses. And also looking at the state of the product and see if these refrigerated warehouses can be pre-cooled so that you can provide some demand relief kind of services is ongoing. Quantifying it, how much, I think it's a little difficult at this point, but there are definitely some efforts underway by traditional refrigeration companies.
And another question: does anyone have case studies of using third-party REST API to integrate into cloud-based applications? Forgive me if that's not how you say that.
This is Julio from Honeywell. In the later part of this year, we'll be launching an entire platform of APIs on the Honeywell Forge platform that I mentioned in my presentation. And the intent is to be able to create this community of data exchange in our cloud platform. So, be on the lookout for that.
Okay. We should probably sign off for now. I'm sorry I haven't been able to get to every question, but we try to keep these to an hour. So please send follow-up questions to the panelists. If you need their contact information, you can email me, Heidi Kurtz at NASCO. Thank you. Goodbye, all.
Thank you.
Hey, everyone.
Bye.
Thank you.